Hi guys, welcome to R2E, and in this video we're gonna solve this problem, that is problem number 2.8 from Daniel Kleppner and Kolenkow. So what the problem says, let's see. So it says that I have these two masses M1 and M2 that are connected to through a system of pulleys and strings, and the strings are massless, inextensible, and the pulleys are also massless and frictionless. And what am I supposed to calculate is the acceleration of m1, right? So the first step is to write the equation of motion for each one of them. So let's say for m1 I write tension minus of m1g equals to m1 x1 double dot. Just for those people who don't know this double dot thing, so if I have some parameter q and if I put a dot over it, it means that I'm taking its first derivative with respect to time, and if I'm putting double dot over it, it means that I'm taking second derivative over its time, and so on. So if there are three dot, it means that it's the third time derivative of that q thing, and q could be anything, any function of time, right? Okay, so yeah, so that's t minus of m1g equals to m1 x1 double dot. And for the second one, I also write for m2, I write t by 2 minus of m2g, that is equals to m2 x2 double dot, right? And the point is here that let's see this pulley, and you have tension T here, so in both of the sides tension should be T by 2 and T by 2 to develop the equilibrium. So yeah, today I have two equations, equation 1 and equation 2. Now what I want is I want x1 double dot, right? But here I have these three variables. I have this x1 double dot, x2 double dot, and tension. So I need to remove, so obviously I want to solve this system of equations where I have three variables but I only have two equations, so I also need one more equation. So what I do is, for that I will write things like this. Let's say x1 plus L1 plus L1 dash plus L2 dash plus L2 plus x2 divided by 2, and this whole thing sorry, and this whole thing is constant, so I will take the time derivative all across the equation. So it will be x1 double dot x1 double dot plus x2 double dot divided by 2 equals to 0. So this implies that x2 double dot equals to minus of 2 x1 double dot. And now, yeah, okay, so many of you might be thinking that why have I written this equation like this? Because most of you guys are used to write it like, okay, so let's say tension m2g is greater than t by 2, so I should write it as m2g minus of t by 2 equals to m2 x2 double dot, right? I mean, most of people usually write it like this, but I'm not writing it like this because I'm not planning to get the direction of acceleration from this equation, because it really doesn't matter how I write it, because from this relation I came to know that the direction of motion of m1 and m2 are opposite. So once I will put this value here, here, I will get my answer correctly. So it really doesn't matter how you write an equation, it's just a negative sign, so it doesn't really matter that much. Okay, so now I will move further and I will write, so t minus of m1 mg equals to m1g equals to m1 x1 double dot, and t2 minus of m2g equals to minus of 2 m2 x1 double dot, right? So yeah, let's multiply this by 2, so it will be 2, let's multiply by 2, so it will be t minus of 2 m2g equals to minus of 4 m2 x1 double dot, right? So let's multiply by negative and add both of them. So they both cancel out, and it's 2 m2 minus of m1, and I get g common, and there it is, 4 m2 plus m1 x1 double dot. So x1 double dot equals to 2 m2 minus of m1 times g divided by 4 m2 plus m1, and here is your answer. Thank you for watching this video.